Yes, class. Good evening.
Good evening, ma'am.
All right. So, see, class, we had completed with EM waves also in the last class, and I had told you that to revise and learn that electromagnetic spectrum. Then we are starting from chapter number 9 of NCRT. That is part 2 book is there no of NCRT. It's first chapter, ray optics. Optics is the unit. So regarding the backup and everything, please discuss it with me, Zain, because in your batch, many chapters are still lagging. And here we are going to start with ray optics, and all the chapters have already been covered. Fine, class. Now see, your book 1 is over. Till EM waves is over. We are going to do the revision also of it, and we are going to perform and give tests also of it. Now, your second book, what all things are important? In your second book, that is book 2 that you have, ray optics and wave optics. These are very important chapters. And among these also, ray optics is the most important. It's lengthy chapter. We are going to devote certain time on this lesson. And then we are going to move to wave optics as we are going through the proper sequence of NCRT only. Now see class, in this lesson, you have to deal with ray optics. Ray optics basically mean all those lenses, mirror, formula, refractive index, prism, compound, microscope, and all these instruments. These are included in your ray optics. Then you have wave optics in your syllabus. So wave optics deals with all the properties of waves and all. So some portions of wave optics you have already studied in class 11th, like interference in brief you have studied. I don't know whether in your batch it was done or not, but in slightly brief we tell in class 11th also. This year you have it in detail, diffraction, interference, all these phenomena. So that will complete your unit optics. Fine. So as I'm repeating, ray optics is the most important lesson. Please do it simultaneously. As the class gets ended, after the class if you get time, or the next day, because you just have 2 classes per week. So apart from those 2 classes per week that are occurring, at least revision of what has been taught in the class, that you can at least do. Whatever topics we have done in the class, just at least revise that much, because ray optics, I'm telling you, it will become otherwise confusing. This time mirrors are also there, so it will become very confusing if you do not revise it simultaneously on a regular and do not perform your self-study on a daily basis. So please revise it. Then after optics, in your second term book, what do we have? We have modern physics. So modern physics, all the lessons are very short. Remember, I have told you till chapter number 4, you have to pay attention and pay emphasis on all the things. And when our chapter 4 got over, within this August and September, rest of the chapters got over, because that till that lesson, it was lengthy. So similarly, after optics gets over, especially after ray optics, you have atoms, you have nuclei, you have dual nature of matter and radiation. All these are very small lessons. And at the last, at the end, you have, that is your ray optics, is your semiconductors. So semiconductors is what? That is the last lesson that we have. Just a second. Semiconductors is the last lesson that you have. So we'll start with ray optics. Now see class, what all things are included in ray optics. Certain changes in syllabus have been done this year. One is a phenomena of reflection. Then you have phenomena of refraction. And within this refraction only, total internal reflection, apparent depth, all these topics are included. All these topics are included within refraction. So you have apparent depth also, total internal reflection, all these topics you have already done. And there are certain phenomena of it. Then after refraction, you have optical instruments. And lastly, you have prism. So reflection got deleted last year. This year, reflection is added back. Reflection includes your mirror formula, spherical mirrors, both concave mirror, convex mirror, and the phenomena and the laws of reflection. That this whole portion was deleted last year, but this year it has been added. So a lot of chances are there that questions from reflection will come. So in today's class, as I've told you, you already have your test today in the second half of this class. So what we'll do, we'll start with the basics of ray optics that is present. We'll start with the basics of ray optics, cover till refractive index. But majorly we'll start with reflection afterwards. Fine, after reflection, we'll start with it. Then you have refraction. Refraction is bending of light, bending of rays of light. That we'll see later on. There you have lenses with you. Convex lenses are there, concave lenses are there. That part is your refraction part. So this was included last year also. This is still included. Then you have optical instruments. Optical instruments are basically your microscope and you have telescope. So microscope also, both the microscopes that are present. Your simple microscope, your compound microscope, both the microscopes that are present. So that is included, and that was included last year also. But reflection, as I'm saying, since it was deleted last year, so chances of questions coming from reflection is more. Then optical instrument, a prism, I'll just confirm once more whether it's still included or not. By far, it's included in your syllabus. I'll just check it once whether this is still included in your syllabus. Fine. So starting from ray optics, see, certain things that are common to refraction and reflection, both the processes. So rectilinear propagation of light, this is common to both reflection and refraction. Rectilinear propagation of light means what? This phenomena of light that it travels in a straight line. This phenomenon. Light that is coming from the source of light, it is striking the eyes directly. It is not moving in a zigzag order or in a Brownian movement. It is moving straight. This path of the light is straight. So that property of light, that it travels in a straight line, that is known as rectilinear propagation of light. Rectilinear propagation of light means what? Light travels in a straight line. Fine. So if this is your light ray, it will go straight away. Now, why do it reflects and why do it refracts? That is a different topic. Refraction and reflection, these are certain processes that can occur. But basic property of light ray for being straight, for being for not being bending of light, you have a different topic whenever it strikes an object. That we'll do in wave. But when we are talking with and dealing with ray optics, you have to remember that light travels in a straight line, and the speed of light also all of you should be knowing, and most of you are aware of this, that this is 3 into 10 to the power 8 meter per second. So with this speed, the light rays travel straight away. Fine. Now they'll strike the object, different phenomena will occur. That's a total different. Second term you have, first was rectilinear propagation of light. Second term that you have is principle of reversibility. Now see, principle of reversibility can be best understood with the help of example. Okay? Let's say I have a mirror over here. I have a mirror here also, and I have kept a mirror like this. Now, certain rays have struck this surface. This is a plane mirror that has been kept. Plane mirror also we'll do the properties and phenomena of plane mirror. We'll do it. Now, see what will happen. Because of the phenomena and the process of reflection of light, this light ray will strike the mirror. Fine, the light ray will strike the mirror surface and it will get reflected. And by how much degree will it get reflected, or why will it get reflected? That is a process that we'll see in reflection, but it will get reflected for sure. It gets reflected and strikes this. Fine. Then at here also, this will also get. Now, if this angle is 90 degree over here, this angle is 90 degree, the light ray will travel the path as it is. Here it will strike, then it will go, then here it will, and ultimately it will move on like this. This is what is meant by principle of reversibility. So I have written the statement also. This principle states that if the path of ray of light after it has suffered several reflections is reversed. I have reversed, no, instead of keeping that mirror at this angle, I could have kept it like this. So again, reflections would have continued. Right now, what has happened? I have kept that mirror in such a way, at such an angle that the light rays are reflecting back. So it retraces its path exactly. You will not get a new pathway. By which pathway the light had emerged, the same pathway the light will go back and retrace its path. Fine. Then you have concept of object and image. Object and images are very important, very, very important, because this is a very basic thing. All of you will be able to understand this fact. Now, object means what? Object means from where the light rays are emerging, the point from where the light rays are emerging. A source is there, like this tube light. This is a source of light. So this becomes an object. Why? Because it is emitting light. Now, object can be luminous or it can be non-luminous. It can be luminous and it can be non-luminous. Now see, when do we say an object is said to be luminous and when it is said to be non-luminous? See, if the sources or rays of light are coming from this tube light, all the rays of light are coming from this, then it means this tube light is emitting the light of its own. Or if we talk about sun, during the daytime, the sun that is risen over there, then what happens? Sun that has risen over there, it also emits a source of light on its own. So because that light, whenever it's fall, it will form an image and rest of the phenomena will occur. But that sun, because it is the source of light, and also the tube light or the normal lamps or bulbs that we have, these are producing or emitting light of their own. They have a certain intensity that we call as luminous intensity or luminosity. SI unit is candela. You don't need to go into the details of it. So luminous intensity means luminous objects are what? They are emitting light of its own. But if I am standing in front of a mirror, I'm able to see myself as well. But I'm not emitting any light of my own, but still I'm able to see myself in the mirror. Reason is that because those luminous objects are emitting light of their own, and those light rays are falling on my surface, on my body, they are falling on me, and then they are getting reflected. So I am also acting as an object now because the light rays are emerging from me right now. Actually, the light rays are from the object, but since they are striking me, and then after striking me, they are going into the mirror. I will be the object whose image is formed in the mirror. So these kinds of objects are known as non-luminous objects, who do not emit their own light, but are a source of light, indirect way. Fine. Now, this was basic luminous and non-luminous, but majorly what you have to remember is real and virtual, the difference between real and virtual. And most importantly, real and virtual becomes important when you have reflection, phenomena of reflection, especially in mirrors. See, firstly, you have a real object. Real object means an actual object or a physical entity that is present in space. Fine. For example, if I say this pen, I keep a mirror over here. I'll be able to see the image of this pen. Any kind of mirror I choose, convex mirror, concave mirror. What are concave, convex? We'll see it later on. But what any type of mirror, even if I choose, what will happen? I'll be able to see the image of this. So when I'm able to see the image of this, it means what? This object is a real object. It is actually present in space. Now, the speciality and the property that you have to remember about real objects is that the rays that emerge from these real objects, these are diverging in nature. Why are we studying this? Because this will be helpful when you will be drawing your ray diagrams. So especially for your ray diagrams, this is important. So these are what? These are diverging rays. Real objects having rays divergent. Fine. Then you have a concept of virtual object. Virtual object. Now, what is meant by this? Suppose, let's say, this is an actual object that is kept in space. Fine. There's a mirror, and I'm able to see the image of it. Now, because I have kept another mirror over here, another mirror I have kept over here. So, what will happen? The light rays from this will strike over here, and I'll be able to obtain another image over here. You can understand this in a way. If you keep two mirrors, you are able to see an image over in this mirror also, and you're able to see the mirrors at the back side also. Infinite images also are formed. So what happens? This was a real object whose image was formed. Now, because another mirror is kept, so in this image that is formed, this is acting as a source of light. But is it actually present in space? Even do our images present physically? No. So it means this was a real object that could be felt, that was actually present. But since this was a source of light, and because of this emergence of light, we say that this is an object. But we put this into the category of virtual object because it is not present. Virtual, when we say virtual and real, in normal English language also, real means something that is present, virtual that is not present. Virtual classes, we also refer to these classes as virtual classes that are happening. So similarly, so this becomes your virtual object this time. This is not an object that is present. This is a real object. But since it is becoming a source of light, we say it's a virtual object. And if you have virtual object in space anytime, so the rays are converging rays. These rays are converging rays. Similarly, now what will happen? These rays will move. All these rays will move. Now, when the rays or the light rays, they will move, at a point they'll emerge only. If the lines are not parallel, at a certain point, these rays or the light rays will meet at a certain point because they are not parallel. If they are parallel, that's a different case. But if the light rays are not parallel, they'll appear, they'll meet somewhere. That point where all these rays will meet, or you're able to see the reflection or the object's image, that point you call as the image. So it's the point at which the rays appear to meet at a point. It can appear to meet, or it will just meet. Actually, it will meet or it will appear to meet. What is meant by this? See. Here also you will be having the concept of real image and virtual image. See what is meant by real image. If the rays actually meet at a point somewhere because of the source of light, because of any point, any source of light that is emitting, these rays are meeting over here, and an image I am able to observe. So these are what type of rays? Converging rays. And here what is happening? Real image is formed. So in case of real object, we had divergent rays, but for real image, we have converging rays. Please remember these points when you have to draw the figures or draw the ray diagrams. These points become important. So for real object, diverging rays, but real image, converging rays. Fine. Now real image means what? Rays actually meet at a point. Rays actually meet at a point. Fine. Then you have virtual image. The way we had the concept of virtual object, here virtual image will also exist. Now here rays just appear to meet. They are actually not meeting. Whenever you have the term virtual, get it in your mind. This is actually not happening. Something is happening in compensation of the other thing. So this is rays appear to meet. And rays are appearing to meet. For example, if I say these are two light rays, right? If I extend them and I produce them, I'm able to observe an image over here. So these become what? This becomes a virtual image. It is actually, the rays were not actually meeting, but if I extend and they were appearing to meet at a point where I'm able to observe the image, that image you call as the virtual image. And convergent rays were present in virtual object. So opposite to it, diverging rays for virtual image. This is diverging. First, tell me, is it clear till here? These are all the basic points, very basic points. Most of you must be knowing it from your earlier classes only, virtual and real, object and images, all these things. But these topics, this image part that we have completed, all these are included in common in both reflection and refraction. Principle of reversibility traces itself. Objects are sources of light, images are where light meet each other. So note it down from here. Wherever you're having doubts, let me know. Good evening, Zed. Zed, you've come here for the backup class of yesterday, or have you joined the batch back?
Ma'am, I'm joined I'm joining the batch back.
Okay. Written class. Let's start with refractive index. See, we'll complete refractive index because it's a very, very smaller topic, and then we'll go into the details of refraction. Before that, we'll complete with reflection because, as I've told you, and I'm emphasizing this a lot, topics that have been recently added in your batch. See, because of COVID and all these online classes and everything, most of the topics got deleted. For the last year's batch that we had, we didn't have to teach reflection. So reflection of lights, we'll start that within the next class only. Today we'll just complete because it's a smaller topic, and after that you have your test also. So refractive index will complete. Now see, normal density you all are aware of. What is meant by density? Talk about density optically for a lens, for a glass surface, that becomes the optical density. And the measurement of that optical density, that is given by this quantity which we say refractive index. Formula or mathematical definition we'll see later. Just understand what is meant by refractive index. For example, one medium is there that is present, that is your air. Fine, this is air. Then you have a medium glass, you have a medium water. So if I keep these glasses inside water and if I try to see, because of the refractive index, because of the difference in the medium that is occurring, there will be a different image that will be formed. Fine, the image that will be formed will be different. Now what will happen if I am able to see through these glasses? These are the medium is air. So every media has its different and dominant role. So because of presence of different media that are present, we have optical densities of that media. Yes, Zephyr, for sure, you can come back. So what will happen? That is known as the optical density. Now C class. If I am able to measure that optical density, how much denser a medium? You have rarer and denser medium, that's a different thing. Normal density is different. The way we have density of water as 1000 kg per meter cube, and the refractive index of water is different. That will be very less, 1.3 or 1.5. This is the refractive index of water. That is a very lesser quantity because this is not that density which we have mass by volume. This is the optical density. How much light rays are able to move through the lens and are able to reflect themselves or refract themselves. That is known as the refractive index. So refractive index means what? It just defines the optical density of a medium. Fine, it defines the optical density of it. Now, refractive index are also of two types. One is your absolute refractive index, and then you have relative refractive index, and both of these are included in your syllabus. And it's not difficult. See, understand what is a refractive index mathematically. Either the ratio of two speeds or ratio of two wavelengths. This is simply your refractive index, fine? Ratio of two speeds of two medium and ratio of two wavelengths in two medium. Speed of what? Speed of light. Wavelength of what? Wavelength of light. So refractive, absolute refractive index is said to be when? When do you have absolute refractive index? Refractive index is said to be absolute when one of the medium becomes there. Remember for your electrostatics also, when we did it, we had epsilon naught. What was epsilon naught? We added that naught, a zero in the subscript to denote what? That it is specifically for air. Yes, air. So epsilon naught, that is 8.85 into 10 to the power minus 12. That was specifically defining air. Then we had mu naught. Why we had mu naught specifically? Permeability. That was showing that permeability for air is mu naught. Fine. So everything, when you compare it with a different thing. That becomes a new quantity. But when you have air as a reference, if the ratio of light of two speeds is given, or ratio of the light's wavelength is given, if one of the medium becomes air, other medium can be anything. It can be water, it can be glass, it can be any other medium. But if one of the media becomes your air, vacuum or free space, which we say, you have absolute refractive index. And relative refractive index is when there is comparison of two media, any media apart from air. If air becomes your medium, then all the concepts get changed and you have absolute refractive index back. Relative refractive index, two speeds ratio are given and the ratio of two wavelengths are given. That's what is refractive index. Both the mediums are different. Let's say in oil and water, two convex lenses are kept. So the relative refractive index will be given. Either refractive index of this glass which is kept in water with respect to oil, or the glass that is kept in oil with respect to water. Like this we say relative. Relative velocity also you must have heard in your lower classes. In your 11th only you had a relative velocity. It was what? Comparison of two velocities. One velocity with respect to other, its value gets changed. So here also, because of presence of different media, the refractive index gets changed. Now, as I've told you, yes, one more thing. It is denoted by small n or mu. Now, small n or this mu, mostly we'll try to use small n because we have already used mu for permeability. And also in your NCRT and in other also books, you can find both n also and mu also. So do not get confused. Concepts remain the same. Fine. Now, this is what I have told you. It's the ratio of speed of light, ratio of speed of light. One of the media becomes air. So in air, the speed of light in a medium, a random. And speed of light in air, we all know that is c. So one of the quantities here it is specified. C has been experimentally calculated and the value of c is known. This can be any value v, some speed of light. And not only this, one more thing I have mentioned is about the wavelength. Wavelength in air to the wavelength in a different medium. Wavelength in medium. Wavelength of air medium. So wavelength of air, I am depicting it through lambda naught. Naught symbol is representing air. And then for medium, I am writing it as lambda. So we can write n or mu as what? C divided by V or lambda naught divided by lambda. That becomes the formula for refractive index. This is the lambda naught by lambda. Now you have relative refractive index. Relative refractive index. So this is what? This is refractive index of one medium with respect to another medium. Fine. This is refractive index of a medium with respect to another medium. So let's say n/1. This is the refractive index of second medium with respect to one. Whichever medium you're taking as the reference, no, write it as first. If I'm talking about the second medium, that is refractive index of second medium, then I'll write 1 to show that it is with respect to the first medium. n/1 is what? It's the refractive index of second medium with respect to 1. So formula, first let me write, this is refractive index of 2 with respect to 1. Now formula will be what? It's Relative, so you take the ratio of both the refractive indices that are present. N21 is given, so N2 by N1. Had it been N12, you would have written N1 by N2. Fine. Now, refractive index is what? Speed in one medium by speed in other medium, or wavelength in one medium by wavelength in second medium, like this only. It's just that here your medium is different. It's not air. Earlier you had it as air in absolute. Fine. If it is N12, it will be reverse. V2 will come upwards. It will be V2 by V1, which is lambda 1, lambda 2 by lambda 1. V1 and V2 are what? I hope you're understanding. This is not speed of light in air that we take. This is some other speed of light that will be given to you in question. Speed of light in medium 1. And V2 is what? Speed of light in medium 2. Like speed of light in medium 1 and speed of light in medium 2. This is only given. Fine. So refractive index, I am repeating. Relative refractive index formula, remember. It's ratio of speed of light in two medium. If one medium becomes air, it's absolute refractive index. If both the media are different apart from air, you have relative refractive index. Now you can use different symbols to denote it. We usually use these symbols: C for speed of light, V for velocity, lambda naught, and lambda. Fine. Let's see a numerical as well. Then you can note it down. This says that a light of wavelength 6000 angstrom enters in air. So this wavelength, this is given in air. That is lambda naught, 6000 angstrom. This is given as 6000 angstrom. So we'll convert this. That becomes 6 into 10 to the power 3 into 10 to the power minus 10 meters. In 6000, and this is conversion of angstrom. 1 angstrom is equal to 10 to the power minus 10 meters. This is wavelength given, that is 6 into 10 to the power minus 7 meters. Refractive index is given 1.5. What will be the frequency and wavelength of light in that medium? See, N is what? N is equal to lambda naught divided by lambda. So wavelength in that medium we can find out. Wavelength will be what? Refractive, from here we can write wavelength as refractive index divided by the wavelength in air. Lambda will be equal to 1.5 divided by this becomes lambda naught. Okay, lambda naught by lambda. Lambda we are finding, no? So this becomes lambda naught by n. See, n is what? N is the refractive index, ratio of two wavelength. Now, wavelength in air is given. So, wavelength in air divided by wavelength in the medium that we are calculating. From here, we are finding lambda. So, that becomes lambda naught divided by n. So, lambda naught is 6 into 10 to the power minus 7 divided by n is what? N is 1.5. So, you get wavelength as 4 into 10 to the power minus 7. 60 by 15 you will get simply. So this is only wavelength. Frequency, how will you calculate? See, for frequency, if we have velocity, we'll be able to manage with frequency. How will you get velocity? You know one of the medium is air. You know the refractive index. You can easily calculate the other velocity. What was refractive index? Refractive index was speed of light divided by the velocity. Now, from here we have to find out velocity, which will be speed of light divided by n. From here, if you calculate, your speed of light in the medium will be given by 3 into 10 to the power 8 meter per second divided by the refractive index, which you have 1.5. So that becomes 2. This velocity becomes 2 into 10 to the power 8 meter per second. Fine. You have frequency in that medium, and you have what? You have wavelength in that medium. You have velocity in that medium. Remember, velocity is the product of frequency and wavelength. So frequency will be equal to what? Velocity divided by wavelength. Velocity is 2 into 10 to the power 8. Wavelength is 4 into 10 to the power minus 7. That becomes 0.5 into 10 to the power 15 hertz. Frequency is given. Got it? See, I am repeating this numerical. What is meant by this numerical? It says that wavelength of light in air is given, refractive index is given. So you can find out the refractive index in another medium. If one of the medium is air, so speed of light in air you already know, and speed of light in that medium can be calculated. When you have the speed of the medium and wavelength of the medium, speed of light in that medium and wavelength of that light in a medium, velocity is product of wavelength and frequency. In that, through the last equation you can calculate the frequency. So this is what all about refractive index. We'll do one more numerical we'll do. Before that, note down this. Any doubts you're having in this, ask me. Rest of the phenomena of refraction and what are the details about it, that we'll see in refraction only. First, we'll complete reflection. Though reflection is easier than your refraction. Reflection, laws of reflection, these are included. Refractive index of glass is given to you as what? 1.5. So this is the refractive index of glass that is given 1.5. Then you have refractive index of water given as 1.3. Did anyone get the answer for this part?
Yes.
Second question. Speed of light in water is 2.25 into 10 to the power 8 meter per second. And velocity means speed of light in glass is unknown. This has to be calculated. So if you write the refractive index of glass with respect to water, this is ratio of 1.95 into 10 to the power 8. Yes, Krishna. Right answer you're getting. So this is refractive index of glass divided by refractive index of water. So this becomes speed. I have told you, this gets reversed. 1.93 into 10 to the power 8. Yes, right, Sarah. Meter per second. Add your units also, both of you, Krishna and Sarah. This becomes what? This is speed in water divided by speed in glass. Now, what is unknown? This is unknown. Rest of the things are known. So Vg will be equal to what? This will be equal to VW multiplied by NW divided by NG. VW is 2.25 into 10 to the power 8. Refractive index of water is 1.3 and refractive index of glass is 1.5. So when you will solve this, you will get the speed of light in glass as 1.95 into 10 to the power 8 meter per second. Note down the solution. When you are done, text me done in the chat room. Then we can have your test of AC. Then you can leave because alternating current, I have not done it with you. So you can escape the test. But rest of the students, we have completed alternating together. Why, Akifa? Reason? Okay. I have seen the message. Okay, fine. Okay, then let's start with your tests. Test of AC. Start the test class. Then you can do one thing. You can take the screenshot of the paper and save it for later. And if you are aware of this lesson, you can attempt it. I have given you the liberty. It's your choice then. Zed, this number is there on the group.
No, ma'am.
Okay. Okay, Zed, just do one thing. Please share this number with Learnivio. They'll just this ID by which you get coordinated by the coordinator. Just send this number once on the Learnivio team. Then just wait for 5 minutes. Let them get added. I'll inform them as well. Just send this number, please.
Sure.
Zed, did you share your number? Hanifa, I've received yours.
Yes, ma'am, I have sent.
Did they see your message?
Yes, ma'am, they received.
Okay.
Ma'am, I have sent the PDF on the Learnivio group. Is it okay?
Okay. Fine. Fatima, you can also leave. Fatima and Hanifa, both of you.
Thank you, teacher.
Zed, I think they have added you on the group. Just check once.
Yes, ma'am, I have sent the PDF.
Okay. Okay, Zed, you can also leave. Josefa Ahmed's also a part. Josefa, you can also leave. Thank you. Hurry up, class. Wrap up your sheets now. Okay, Kulsum, just let me know once it gets uploaded. Others also, please wrap up your sheets now. Sarah, you can leave. Sarah, I've got yours.